I am Dr.K.Nirmala Jyothi, HOD of Chemistry, JNJ College for Women, Tenali. Today I am going to discuss about coordination compounds. First we discuss about the coordination compound. So what is coordination compound? The transition metals form a large number of complex compounds in which the metal atoms are bound to a number of anions or neutral molecules. In modern terminology, such compounds are called coordination compounds. This is the best example of coordination compound. So, this indicates the central atom. These are called ligands. These are the examples of coordination compounds. For example, this is hexaamine cobalt chloride. So, this CO indicates the D block element or transition element. These ammonia molecules are called as ligands. Next one, diamine silver ion. Here silver is a central ion, ammonia molecules are called ligands. Next one, another example, tetra aqua dichlorochromium. This 3 numerical Roman letter indicates the oxidation state. Next one, these coordination compounds are used in many applications are there. So, these are used in animal and plant kingdom. These are the main applications. One is extraction of metal. For example, extraction of metal. So, silver and gold. Simple example, silver and gold. These are extracted from ores by metallurgical process. This is another application, analytical chemistry. So, in an analytical chemistry, both qualitative and quantitative analysis are used in analytical chemistry. Biological importance. Haemoglobin is the best example of coordination compound. In medicine, so medicine also, so many coordination compounds are used in medicine. Next one, in electroplating. Another one is for estimation of hardness of water. This is also most important. In modifying the redox behavior of metal ions. Next one, coordination compounds play many roles in the animals and plants. They are essential in the storage and transport of oxygen. For example, hemoglobin, this is a complex compound. Hemoglobin, iron is a central ion. This hemoglobin carry the oxygen from lungs to tissues and tissues to lungs. It is also used as electron transfer agent. It is also used as catalyst and in photosynthesis. For example, in photosynthesis reaction, chlorophyll is having magnesium. Magnesium is a metal, it belongs to D block element. So, another one is medicine, cisplatin, it is used as anti-cancer drug. Next, this is the structure of hemoglobin. Here iron, it is a central ion. These surrounding ions are called ligands. Next one, this structure of hemoglobin, it is having, the molecule contains 4-fold long chains called subunits. Hemoglobin carries oxygen in the blood from the lungs to the tissues, where it delivers the oxygen molecules to myoglobin. This myoglobin, which is made up of only subunit, stores oxygen for metabolic process in muscle. These coordination compounds are used as catalysts for many industrial processes and have many applications in qualitative and quantitative chemical analysis within analytical chemistry. For example, it is used to detect cupric ions in the salt. When copper sulfate solution is mixed with aqueous ammonia, a deep blue complex soluble in water is formed. The importance of coordination compounds in biological system and also that coordination compounds play a vital role in metallurgy and medicine. So, this is the metallurgical process. So, noble metals like silver and gold are extracted from their ore by the formation of cyanide complexes, that is dicyanoargentite and dicyanoorate. So, first we know the definitions of double salt and complex salt. These are the difference between double salt and complex salt. This is double salt. It is the combination of two salts. A double salt is a compound prepared by the combination of two different salt compounds. This is complex salt. A complex salt is a compound composed of a central metal atom having coordination bonds with the ligands around it. One of the best examples of complex salt is potassium ferrocyanide. Here example is alum, potash alum. These are completely dissociate into its ion in water. Do not completely dissociate into its ions in water. Give simple ions when added to water. So for example, potash alum, it gives ions. Completely these are soluble in water. These are not gives the ions because these are insoluble in water. Can easily be analyzed by determining the ions present in the aqueous solution. Cannot be easily analyzed by determining the ions in aqueous solution. So these are the examples of double salt and complex salt. For example, carnallite. Carnallite formula KCl dot MgCl2 dot 6H2O, carnallite. Next, another one is more salt. Ferrous salt, FeSO4, ammonium sulfate, water. Next, complex salt, potassium ferrocyanide is a complex salt. Next, some important terminology is used in coordination chemistry. First, we know the definition of Lewis acid. Lewis acid means all electron acceptors are called Lewis acids. What is Lewis base? All electron donors are called Lewis base. So, in between metal and ligand, so coordinate covalent bond is formed. This bond is formed between a Lewis acid and a Lewis base. The ligands means Lewis bases have non-bonding electrons. The metal Lewis acid has empty. This is the example of metal ligand band. So silver ions with the ammonia molecules. Next, another important terminology is used in coordination chemistry, that is central metal ion and oxidation state. Central metal ion is in the complex ion an acceptor accepts a pair of electrons from the donor atoms. The acceptor is usually a metal or metal ion to which one or more of neutral molecules or anions are attached. The acceptor metal cation is referred to as central metal cation. Hence, central metal cation in a complex serve as a Lewis acid. So another terminology is used, that is oxidation state. This denotes the charge explaining the number of electrons it has lost to form the cation. It is oxidation number that denotes the charge. If the central metal ion would have, if all the ligand in the complex were removed along with their electron pairs that were shared with the central atom, it is usually presented by Roman numericals. Next, another important terminology is ligand. So what is ligand? A ligand is an ion or a molecule capable of functioning as an electron donor. Therefore, the neutral molecules or ions which are directly attached to the central metal ion are called as ligand or coordination groups. These coordination groups or ligands can donate a pair of electrons to the central metal ion or atom. Hence, in a complex compound, ligands act as Lewis bases. Next one, this is the classification of ligands. The molecules or ions which are coordinated to the metal atom or ion in a coordination compound are called ligands or donor groups. It is based on the number of donor atoms in ligand. The ligands are classified into the following types. It is depends on the number of donor atoms. For example, monodendrite, it donates only one pair, lone pair of electrons. So examples are water and ammonia. Bidendrite, it donates the two lone pair of electrons. For example, ethylene diamine, DMG and oxalic acid. Tridendrite, it donates the three lone pair of electrons. That is diethyl triamine. Tetradendrite, it donates the four lone pair of electrons. Triethylene tetraamine. Last one is hexadendrite, it donates six lone pair of electrons. This is the best example, EDTA. Next one, this is the structure of ammonia. This belongs to monodendrite. This is ethylene diamine. This is the structure of EDTA, hexadendrite. Next one, types of ligands. Unidendrite ligand, ligands with only one donor atom, for example ammonia and water, chloride, etc. Bident ligands with 2 donor atoms, example ethylene, diamine or oxalate ion. Tridentate ligands which have 3 donor atoms for ligand, for example diethyl triamine. Hexadentate ligands which have 6 donor atoms for ligand, EDTA. Next, another one is chelating ligands. Multidentate ligands simultaneously coordinating to a metal ion through more than one site is called chelating ligand. These ligands produce a ring-like structure called chelate. Chelation increases the stability of complex. This effect is called chelation effect. Next, another terminology is used in coordination chemistry is coordination sphere. So, what is coordination sphere? While writing the structural formula of a given complex ion, the ligands which are directly linked with it are enclosed in square bracket, which is called coordination sphere. This coordination sphere consists of the central metal atom or ion and the ligands attached with it. Thus, in the complex compound, this is a complex compound, the coordination sphere consists of one cobalt ion and 6 ammonia molecules which are acting as ligands. This is another example of coordination compound. This indicates the whole terminology. For example, this is iron, this central metal atom. These are the cyanide ions are called ligands. This 6 indicates the coordination number. Coordination number means this iron is surrounded by 6 ligands. This is called coordination number. This whole is put in square bracket. It is called coordination sphere. Next one, coordination number. Number of ligand atoms bonded directly to the central metal atom. For example, here coordination number is 6. This central ion is attached with 6 ammonium molecules. So, the coordination number is 6. Here coordination number is 2 because 2 ammonium molecules are attached with the silver central ion. So, this is number. Next, another one, here coordination number is 6. So, this is the structures of linear structure, tetrahedral, depends on the coordination number. This is trigonal bipyramid or square pyramid. This is octahedral. Complex compound. Compounds that have complex ions are called complex compounds. As the central metal ion in the complex ion forms dative or coordinate covalent. So, here in coordination chemistry, coordinate covalent bond, it is attached with the central metal ion and ligand. These are attached with coordinate covalent bond. Here metal atom. These are ligand. These are attached with coordinate covalent bonds. Next, another one is charge number of complex ion. The net charge carried by complex ion, charge number of ferrocyanide is equal to charge of ferrous ion plus 6 into charge on Cn minus ion. It is negative charge minus 1 is equal to plus 2 plus 6 into minus 1 is equal to minus 4. This indicates the charge of complex ion. Next, these are the another examples of oxidation number of the central metal atom is calculated as this. So, thank you.